Hi everyone, welcome to another video of calculus. So today I will talk still about the bijective functions, and I will talk about exponential and logarithmic function as well. So let's say a function is bijective if it is both surjective and injective. So that means that for every b inside of b, there exists a inside of a, there exists a unique a inside of a such that f of a is equal to b. So I will leave it to you as an exercise, and at the end of each section, I will have my colleague Martin do an exercise about all of these stuff that I covered. So let's look at bijective functions. 1, 2, and 3. A, B, and C. If we send 1 to C, 2 to A, 3 to B, this is a bijective function. So, bijective. Let's look at functions that is surjective but not injective. We send 1 to A, 2 to B, 3 to A. So this function is surjective but not injective. This function 1, 2, and 3, 1, 2, 3, and 4, we send 1 to 1, 2 to 2, 3 to 4, but we can see that there is no arrow that goes to 3. So there is no input that hits 3. So this function, but you can see that it is bijective because for each output there exists a unique input that goes to it. So this is injective, but not surjective. You can have a function which is both not surjective and not injective. 1, 2, and 3. 1, 2, 3, and let's get letters instead. A, B, C, and D. Send this to and so this function is not surjective and not injective. So not surjective or injective. So let's look at functions from R to R. F from R to R, where f of x is equal to x plus 1. It's an exercise to prove that this function is surjective and injective. I suggest that you pause the video and do it by yourself, but I will do this example. And injective. So, suppose B exists in R. And then consider A is equal to B minus 1. So f of A is equal to, whenever you see an x, you substitute B minus 1. So B minus 1 plus 1. So that's equal to B. Suppose that you have f of x. F of x1 is equal to f of x2. So that means that x1 plus 1 is equal to x2 plus 1. So therefore, x1, by subtracting 1 from both sides, x1 is equal to x2. So this function is surjective and injective. So it's a bijective function. Hence, bijective function. So let's see, given this example above, we want to see function composition. So if you have functions f from a to b and a function g from b to c, you can produce another function where the input is a and the output is c, or the allowable output is c. So what you do is you start from a and then you feed that to b, to g. So g composed. So this is the definition for composition. So g composed with f at the point x. It is defined as g of f of x. So whenever you see an x, you substitute f of x instead. So let's see an example. F from a to b is equal to, let's do some easy example first on R. And g from R to R, where f of x is equal to x minus 1 and g of x is equal to x squared plus 1. So g composed with f at the point x is equal to g of where the input that you feed to g at the point x is x minus 1. So next thing is that you replace, whenever you see an instance of x, you replace it with x minus 1 instead of just x. So x minus 1 squared plus 1. All right. So next thing, Let's see an example where we have 1, 2, 3, and 4. So we have a map where it sends here 1, 2, ABC, A, B, and C, where we send 1 to 1, 2 to B, and 1 to A, not to 1, and 3 to C. And here, and 4, we send it to B. So here, I and double I, we send A to double I, B to I, and C to double I. So that means that we send 1, let's trace it, 1 sends to A and then sends to double I. So that means that 1 goes to double I, 2 sends to B, and then B goes to I. So that means that the function G and F sends 1 to double I and 2 to I. All right. And etc. We can do the same thing. 3 sends to C and C sends it to double I. So that means that 3 goes to double I. 4, you send it to B, and then B send it to I. So that means 4 gets sent to I. All right, I hope that this makes sense. And I will touch on, like my friend Martin and colleague, will touch on exercises about this after this section ends. All right. So let's see an example again with F from R to R and G from R to R, where the first F is x plus 1 and the second F is sine G of x is equal to sine of x squared plus 1. So you do G composed with F at the point x. So this is equal to G at x plus 1. So whenever you see an instance of x, you replace it with x plus 1. So this is sine of x plus 1 squared plus 1. All right. So yeah, thank you everyone for watching this video. Next time I will start with exponential function and logarithmic function. All right, I will see you guys in the next video, and I hope you guys enjoyed this video. Bye.